children, today we are going to study the lesson Electromagnetic Induction. Lesson 3 of class 10. Lesson 10 of class 10. In the picture, you can see a boy and a girl is talking each other. They are talking about a device. Did you ever see this device? Yes, it is generator. Do you know? This device is generator. What is the use of this device? Do you know? Yes, it produces current. Do you ever think of how this device produces current? In our picture, a boy and girl is talking each other. They are talking about the device that is generator. Girl is saying that this machine supplies the electricity required for all stages, Babu. Then Babu think that how does it generate electricity? How does it produce current? School Kalosum is undergoing there. For all the stages, this generator gives current. Then Babu has a doubt. What is the doubt? How this device produce current? Can you clear Babu's doubt? You know that electrical energy converted into many other forms. Electrical energy can be converted into light energy. In the previous class you studied about it. It can be converted into magnetic energy. It can be converted into mechanical energy. Electrical energy can be converted into chemical energy. You know that a solar cell converts solar energy into electrical energy. Nowadays, we use solar energy for various purposes. In most of the houses, there are solar heaters, solar water heaters. One solar cell can convert solar energy into electrical energy. We can convert the sunlight into electrical energy. We can convert solar energy into electrical energy. Which are the other form of energy that can be converted into electrical energy? Do you ever think of? We can look. How can we convert magnetic energy into electrical energy? How can we convert magnetic energy into electrical energy? You know that in the previous chapter we studied a conductor in a magnetic field experiences force. You kept a conductor in between the poles of a magnet. Then you passed the current through that conductor. Then what happened? They experienced a force on the conductor. Due to that, the conductor moved. The electricity is generated when conductor is moved in a magnetic field. By using current, we moved a conductor. The conductor experienced a force in between the poles of a magnetic field. Likewise, can we get current by using this magnetic field? It was Michael Faraday. He did experiments about it and discovered the current. He invented the current. By using magnetic field and a conductor, he produced current. Due to that invention, our world changed. Without current, we cannot imagine a life, isn't it? For doing the experiments, we need some materials. We need a magnet. We need a solenoid and galvanometer. We can arrange the materials as in the picture. We should insert a magnet into this solenoid. When inserting this magnet into the solenoid, this galvanometer moves. This galvanometer moves. We are going to watch this experiment. We already told that electrical energy can be converted into various other forms. Chemical energy, magnetic energy, mechanical energy, light energy, isn't it? Yes. When north pole is inserted into the magnet, galvanometer deflects to the right, isn't it? Once again, while inserting this magnet into the solenoid, what happened? Galvanometer moved. The needle of the galvanometer moved. When it pull out, that time also galvanometer moved. We are going to watch another one also. Now the magnet is inside the solenoid. It is taken out. It is pulling out. Then what happened? Galvanometer deflects. The needle of the galvanometer deflects. When it is steady, when the magnet was not moving, there was no deflection for the galvanometer needle. When the magnet was stationary inside the coil, there was no any deflection. When it is inserted into the solenoid, what happened? The galvanometer needle deflected. When the magnet was outside the solenoid, then also there was no any deflection. When it is inserted into the solenoid, what happened? Galvanometer needle shows deflection, isn't it? Yes. When it was steady, when the magnet was not moving inside the solenoid, then what happened? There was no deflection for the galvanometer. When it was taken out, when it was pulled out, when the magnet was pulled out of the solenoid, then that time also galvanometer shows deflection. Okay? From this we can understand that a small current is produced there. Galvanometer is a device used for detecting small current. In 9th standard you studied about it, isn't it? Yes. From the deflection of galvanometer needle, we can understand that during the movement of this magnet inside the solenoid. When it is taken out and when it is inserted into the solenoid, there is a deflection in the galvanometer. This deflection shows yes, current is produced there. Current is produced there. Galvanometer is a device used for measuring small current. Here a small current produces when the magnet is inserted into the solenoid and when it is pulled out. That time also current produces. When the magnet was outside the solenoid, there was no deflection. That time there was no production of current. When the magnet was steady inside the solenoid, that time also no current was produced. We can conclude what we studied in a table. We can write in a table. Can you say the magnet is stationary near the solenoid? Are there any deflection? No. Does not deflect. Galvanometer needle does not deflect. If north pole of the magnet is moved into the solenoid, what happens? Yes, galvanometer needle deflects to the right side. Galvanometer needle deflects to the right side. Isn't it? Yes. The magnet is stationary near the solenoid. Are there any deflection? Oh, no deflection. The magnet is moved out of the solenoid. During that time also deflection. Now the deflection is deflection to the left. Now the deflection towards left. The south pole of the magnet is moved into the solenoid. That time also magnetic needle of the galvanometer deflects. That time also to the left. If we move magnet and solenoid in the same direction, there will not be any deflection. There will not be any deflection. If the magnet and solenoid are moved in the same direction, in the same speed, there will not be any deflection, children. The solenoid is moved keeping the magnet stationary. That time also there will be deflection. In any of the case, if the solenoid is moved, that time galvanometer shows deflection. If the magnet is moved, instead of solenoid, the magnet is moved. That time also galvanometer shows deflection. That time also current is produced. We can watch another one. When we insert this magnet into the solenoid, what happens? Current produces and bulb glows. While taking out, what happens? That time also current produce, bulb glows. While inserting magnet into the solenoid, what happens? Bulb glows. There current produces. When it is taken out, that time also current produces. That time also current produces, bulb glows. When the magnet is kept stationary inside the solenoid, there was no deflection. Bulb doesn't glows. The magnet is outside the coil, outside the solenoid. The magnet is kept outside the solenoid. That time also there was no any deflection. The magnet is moved, or if the solenoid is moved, then there will be deflection. The direction of this deflection changes when we inserted this magnet into the solenoid and when it is taken out. If we change the poles, if we are inserting south pole instead of north pole, what change was occurs? We can look. Here the poles changed into the south pole. Then what happened? Direction of deflection changes. Isn't it? The direction of deflection changes. Now it moves to the left side. When it is taken out, it moves to the right side. Isn't it? The direction of movement of the needle become opposite when we change the poles of the magnet. Isn't it? Children, can you say what happens if we increase the number of turns of this solenoid? We can look. We increase the number of turns now. We are going to insert this magnet into the solenoid. Then what happened to the glowing of the bulb? Yes, glow of the bulb increased. This shows production of current increased. Strength of the current increased. Intensity of the current increased. What happened if the number of turns are less? Yes, glow of bulb reduced, isn't it? Yes. The number of turns are more. Intensity of the bulb, intensity of the glowing of bulb increased, isn't it? Yes. We can insert magnetic field lines also. You can see magnetic field lines there. What happened to these magnetic field lines when we are moving in the magnet? This flux changes, isn't it? Yes. Due to this change of flux, variation in the flux, current is produced. This phenomenon was discovered by Michael Faraday. This phenomenon was discovered by Michael Faraday. We can conclude what we studied by drawing a table. The magnet is stationary near the solenoid. Galvanometer needle does not deflect. The north pole of the magnet is moved into the solenoid. Galvanometer needle deflects, but to the right. Direction to the right. The magnet is stationary inside the solenoid. There was no deflection. Needle does not deflect. Galvanometer needle does not deflect. The magnet is moved out of the solenoid. That time also galvanometer deflects, but to the left side, because the magnet is taken out, pulled out of the solenoid. The south pole of the magnet is moved into the solenoid. That time also galvanometer needle shows deflection, but to the left. Magnet and solenoid are moved in the same direction at the same speed. There will not be any deflection. The solenoid is moved keeping the magnet stationary. That time also deflection. After that, we increase the number of turns, isn't it? Yes. When the number of turns increased, what happened? Deflection of galvanometer needle increases. If we use strong magnet, that time also the deflection of galvanometer needle increases. If we move magnet or solenoid with greater speed, that time also galvanometer needle moves in increase. Movement of galvanometer needle increases. What is the reason? Yes, intensity of current increases. Intensity of current increases. Okay. On the basis of the above experiment and analysis of the table, find out the answer to the following questions and write them down in your science fair. About it, we can study in the next class. Okay, thank you.